Okay, today, sorry guys. All right. So yeah. We continue our lesson about using displacement reaction. We're still in this topic using displacement reaction under the reactivity series. So previously we have learned about how aluminium displaces iron oxide. Why aluminium can displace iron oxide? Because aluminium is more reactive than iron. So the displacement thing is about the concept of displacement is where the reactivity the more the high reactivity of the elements can displace the less reactivity of the elements. That means that it can displace mean it can move. Okay, it can yeah, move that element, kick that element. For example, here A is more reactive than B, so A can kick the B from this BC combination, so it become only B and AC. Why? Because A is more reactive than B. If A is less reactive than B, it cannot. This thing cannot happen. This reaction cannot happen. Okay, so reactivity play a very crucial role in this displacement reaction, right? So let's displacement using carbon. So carbon is not a metal, but it can be used to displace some metals from their compounds. Carbon will displace zinc, iron, tin, and lead from their ores. Why carbon can displace this thing? Because you still remember the reactivity series mnemonic. Please stop calling me a careless zebra. Instead, try and learn how to score per safe goal. So carbon is more reactive. So if you see that reactivity series, you can see that carbon is more reactive than zinc, iron, tin, and lead. So that's why it can displace these things. So an ore is a rock that contains a metal compound. So people discovered that a carbon could displace iron around 3,500 years ago. For example, here I wrote ancient Egypt. So they discovered that iron ore heated with charcoal, a form of carbon, at very high temperatures produced molten iron. Today, this displacement reaction is still carried out on a large scale in the blast furnace. So the iron is mainly iron oxide, right? So this react with carbon to form iron and carbon dioxide. So for example, iron oxide, so carbon. So carbon is more reactive than this what do you call this thing? Combination. Alright. So it can kick iron from iron oxide, so it becomes iron plus carbon dioxide. You just need to remember, so A plus BC. So BC, that B must be less reactive than A, right? So the single element here must be must be more reactive than the compound over here. Understand? That's all. The concept is that's all. So for if this single element is less reactive than compound over here, it cannot undergo the displacement reaction. Alright. So you must make sure the single element is more reactive than the compound over here. So if this single element is more reactive than compound over here, we call it compound because it contains two or more elements. So if this single element over here is more reactive than compound, so it can undergo displacement reaction. That's the uh, the idea, right? So look here, this is what we call the blast furnace. So you have iron ore and coke, a form of carbon are added. So iron being displaced from its ore by carbon. Why? Because simply carbon is more reactive than iron. Please remember the mnemonic, guys. Please stop calling me a careless zebra. Instead, try learn how to score perceived goals. Okay. So air is blown into the furnace to burn the coke and create the high temperatures needed for the reaction. Molten iron collects at the bottom. This is how the blast furnace works. So I hope you understand about the displacement reaction. Okay, please remember the single element must be reactive than the compound so it can kick the compound out. Okay, so and please remember the reactivity series mnemonic. Please, potassium, stop, sodium, calling, calcium. Please stop calling me magnesium, aluminium, careless, zebra. Instead, try and learn how copper safe. Okay, so that's all for now. Thank you guys. Thank you for listening, and don't forget to do your homework in your G form. It will help you with carry marks. Okay, bye. Oh, sorry, not by yet. You have summary. Summary, the thermite reaction is a displacement reaction which can be used to weld railway lines together. Displacement reaction are used to extract some metals from their ore. For example, this is the example of blast furnace. Okay, so that's all. This is the uses of displacement reactions. Why we need displacement reaction? Because we need to extract some metals from their ore. That's all. Alright, so this is the summary. So please, gentle reminder, I want you to do your homework in your G form. Okay, that's that's all, guys. Thank you. Bye.